Hey everyone, so today we are going to see the unique lock in detail. So let us start with the properties. Till now we have seen the lock guard. So unique lock is more powerful than lock guard. It can be unlocked or relocked in between the constructor and the destructor of the lock itself. We can also use deferred locking, and it is very much needed for the condition variable. So these are certain properties that unique lock holds. Let us see all of this with an example. So I'll create a new file, unique lock.cpp, hash include iostream, and we would also require hash include mutex using namespace std. Now we'll again be creating the same function, which was the print function, which is going to log out the thread ID, and we will try to synchronize it or make it thread safe for multiple threads. Void print, we have int thread ID. Now inside this, we have just cout thread ID will be equal to thread ID. Now, once this is done, we can see this print function is a normal function, but it is not thread safe right now. So earlier we used the lock guard. We can also use unique lock here. So I could have done unique lock, which takes a mutex. I'll give it a name LCK and I'll pass the mutex. So till now we have not created a mutex. Let us create one. So mutex mtx. So we created a mutex, we passed it into the lock. So when the constructor will be called, it will automatically get locked. And when it goes out of the scope, it automatically unlocks itself. So this property was also given by the lock guard. But the property that is not given by the lock guard is I can say lck dot unlock over here. And anything written after this is not critical section. So a lock guard cannot be unlocked in between, whereas a unique lock can be unlocked in between. This is why we need it for the condition variable, because condition variables requires the lock to be unlocked in between. So hopefully you have understood the major difference between the unique lock and the lock guard. Now let us also see an example for deferred locking. What we'll do is we'll create another function called deferred lock. And inside this, we don't need any arguments, so let us leave it. So what a deferred locking does is, right now in the previous example, you saw that when we create the unique lock, it will automatically lock itself. So this is the same behavior which was seen in the lock guard. But a deferred lock says that even if I create the unique lock at some point, or when my constructor is getting called, I don't need to lock at that point. At some other point later in the code, I'll try to lock it. So what we do here is unique lock. Inside this, we pass a mutex. So let us name it again LCK. Right now we will pass a mutex, but along with that, we are also going to say defer lock. Now by passing this, we actually say that do not lock at this point. Just create the unique lock, but do not lock it. So whatever written after this, let us say cout deferred locking. Now, I could say that this is not a critical section. What a critical section is, when I call lck.lock, after this, anything becomes critical section. Now I can leave it without writing lock.unlock so that when the deferred lock function is over, the lock will automatically be released. Or otherwise, I could have also said lck.unlock. So hope you have understood the difference between the deferred locking and the normal locking, which we have seen in both the examples parallelly. Now let us also see try to lock. So unique lock also allows us to use try to lock. So let us create another function, which is void try locking. Now inside try locking, what I'll do is again create a unique lock, mutex. I'll give it a name LCK and again pass a mutex, but this time I'll just pass a tag try to lock. So you can see we have gotten suggestion. So when we pass try to lock, It says that try to acquire the lock. If you're not able to own it, then move forward. So we have an if condition, lck dot owns underscore lock. So we are going to check whether we have acquired the lock or not. At this point, we are going to attempt to acquire the lock. If it acquires, then this condition will become true. It means that it is going to print cout lock acquired, right? But in case it fails to acquire the lock, then it will fall back to an else condition, and we can do some operation over there as well. Lock not acquired. So you can see, based on whether you are able to acquire the lock or not, based on that, you can perform certain operations by using try to lock. So hope you have understood all these concepts. I'm not going to use the recursive mutex as of now because you have already seen the examples with the lock card and the syntax is going to remain the same. So these were a few new concepts that I've shown you with the unique lock. In the next video, we are going to see the scope lock. So do like and subscribe the video. Thank you so much.